Alright students, in this session we are going to discuss about the past paper questions of your calculus that includes differentiation and integration. So I will pick up some of the questions from the past papers. As you can see on your screen, there you can have the axis of the past paper variant. So it's December 2003 paper 1 question number 8. Alright, so that is how we are going to understand the nomenclature of question. The question says y is equals to ln x divided by 2x plus 2. And for first part you need to start with the differentiation, right? So you have two functions and they are dividing, so you need to apply quotient rule here, that is u upon v, and I hope that all of you remember the working formula. But in case you forget, so it's derivative of u upon v, it is equals to, in the division we have v square, working formula v derivative of u minus u derivative of v. Alright, you need to learn that working formula so you can apply it easily. So first you need to give it a try first, and for derivative part you have a time of 2 minutes, so start. Alright, so if I pick the functions here, so u is equals to ln x and u dash is equals to 1 divided by x, v is equals to 2x plus 3 and v dash is equals to 2, right? Other working formula. In the denominator we have v square, and v is what? It's 2x plus 3 whole square. Now it says v it's 2x plus 3, derivative of u it's 1 upon x, minus u is ln x, and derivative of v it's 2. Further we can say that it's 2x plus 3 times 1 upon x minus 2 ln x divided by 2x plus 3 and whole square. We can take numerator LCM in the numerator. So in numerator it's 2x plus 3. The LCM in the numerator part it's x minus 2, this x times ln x, right? Divided by, in the denominator it's 2x plus 3 whole square. So now it will be 2x plus 3 minus 2x ln x divided by, it's x times 2x plus 3 whole square, and that is your answer. Alright, so that is the quotient rule differentiation we have. And after that, for part 2, it says the approximate change in y as x increases from 1 to 1 plus p. Now you see that in your past papers the first rule is dy by dx, the next one is a small change, and the third one is chain rule. So it covers your 3 topics, your chapter number 15 and chapter number 16. 2 topics completely covered in this one question. Alright, so for part 2 it says that we need to find out delta y, right, and the value of delta x is equals to p. So the working formula we have is delta y over delta x is equals to dy over dx, right? The value of dy over dx we have already find out in the previous part, it's this one, right? But it says x increases from 1 to 1 plus 2, 1 to 1 plus 2. So the change in x is p and the original value of x is 1. So we need to place the value of x is equals to 1 in this expression. So 2 times 1 it's 2 plus 3 minus 2 ln of 1 divided by x is 1, 2 plus 3 and whole square. On the left side delta y is unknown and delta x is equals to p. Now the question is easy to solve right now. So 2 plus 3 is 5, ln 1 is 0, divided by 2 plus 3 is 5 square is 25, and it's delta y over p, and delta y is equals to 5 ones are 5, 5 5s are 25, it's p divided by 5. Alright, so that is your answer for delta y. And if you remember the concept of a small change, then it's brilliant. But if you don't remember, I hope that all of you are clear after the solution. So you need to write down the solution in your copy, and for that part we have a time of 40 seconds to start. Alright. For the third part, it says the rate of change of x at the instant when x is equals to 1. Alright, we need to find out dx upon dt. Alright, and y is changing at the rate of 0.12 units per second. dy over dt is given at 0.12 units per second. We need to find dx upon dt. For the basic working formula of chain rule, it's dy over dx, dy over dt, chain rule. Dy over dt is equals to dy over dx times dx over dt, right? The value of x we have, it's 1. That is, we need to find out dy by dx. Dx upon dt is what we are looking for, and dy over dt is 0.2. Alright, so why don't you give it a try first, and I've told you all the data here and how to solve the values here. So first give it a try, and you have a time of 90 seconds to start. Alright, so firstly, dy by dx when x is equals to 1, what we had find out here, right? So dy by dx, it's basically 1 over 5, right? Dx upon dt is what we are looking for, and dy over dt is 0.12. So 0.12 times 5, that will be 0.6, is equals to dx upon dt. Alright, and that is your answer. Now if you observe, or if you recall, that when you apply chain rule for all the book questions, in majority of the cases, in fact I say that 90%, this parameter is unknown, right? And in your past paper question you can see that this parameter is unknown. So the concept is almost, in fact the concept is same, but what you need to find out is a little bit different. So you need to be very conscious while attempting any chain rule question, because the working formula is not changing, but what you need to find out is going to be changed. Alright, so I hope that it is clear to you. Moving towards the next question. Again from the past papers, it's an easy question, not difficult. It says, given that y equals to 3x minus 2 over x squared plus 5, you need to find out dy by dx. Simply apply u upon v here, but make sure that you are doing it right. So give it a try. You have a time of 2 minutes, so start. Alright, so before applying u upon v, we need to assign u and v. So u is what? It's 3x minus 2. U dash, it will be 3. Similarly, v is x square plus 5, and v dash, it's 2x, right? I hope that all of you remember the working formula. In the denominator we have v square, and v is what? It's x square plus 5 whole square, right? It says v x square plus 5, derivative of u, it's 3, minus u, 3x minus 2, derivative of v, it's 2x. Alright, we need to simplify it, so I'm going to expand the brackets in the numerator. So it's 3x square plus 3 5s are 15, minus 2 times 3, it will be 6x square, minus minus plus 2 2s are 4x, divided by x square plus 5, and it's whole square, right? So 3x square and minus 6x square, it's minus 3x square. 15 and 4x are as it is, right? And in the denominator it's x square plus 5 and whole square. Alright, so now we cannot simplify it further, so I'll say that that is my answer to this one. Alright, So you can see that the basic concept of u upon v and u into v, you will observe this concept many times in your past papers. So make sure that before proceeding further and attempting more questions, you have a good command on the subtopics we have studied from the beginning of differentiation. Moving on towards the next question. Alright, it's June 2004, paper 2. It is given that y is equals to x plus 1 times 2x minus 3 over 2. Show that dy by dx can be written in the form of kx times root 2x minus 3 and state the value of k. Now this type of question is of 4 marks and basically it is an application of u into v. Alright, so first give it a try and you have a time of 2 minutes, so start. Alright, before starting we need to assign u and v here. So u is x plus 1, u dash it's 1, v is 2x minus 3 to the power 3 upon 2 and v dash. Now we need to derivate the function. First we need to write down the power, it's 3 upon 2, 2x minus 3, 3 upon 2 minus 1, 3 upon 2 minus 1, taking LCM 2, 3 minus 2, it's 1 upon 2. So 3 upon 2 minus 1 leads to 1 upon 2 and the derivative of the function is 2. Alright, so this 2 and 2 cancels here. So what we have is 3 times 2x minus 3 with the power 1 upon 2. Alright, now we need to assign the working formula. U into v is u derivative of v plus v derivative of v. So what u is x plus 1, derivative of v is 3 times 2x minus 3 with the power 1 upon 2 plus v is what, 2x minus 3 with the power 3 upon 2 and derivative of u it's 1. Now we can see that 2x minus 3 can be taken as common, but what 2x minus 3 or which 2x minus 3 should be common? For taking common, keep in mind that we need to pick out the lowest power, right? So the lowest power we have, it's 1 upon 2. So 2x minus 3 power 1 upon 2 we take as a common. Inside the bracket is 3 times x plus 1 plus. Now 3 upon 2 was present and in that 3 upon 2, 1 upon 2 we take common. So 3 upon 2 was initial and 1 upon 2 we take common. So what is left? It's 1. So the leftover part, it's 2x minus 3. Alright. Outside the bracket, it's 2x minus 3. 1 upon 2 means under root. If you multiply the bracket, it's 3x plus 3 plus 2x minus 3. Plus 3 and minus 3 cancel. So you have 5x inside the bracket and the root we have, it's 2x minus 3. If you compare it, what is given you in the question, it's k times x under root of 2x minus 3. So this 2x minus 3, since I am getting the same expression and that is what is already given in the question, it proves that the solution is right and the value of k is equals to 5 and that is your answer. Alright. Now moving on towards the next one. Find in terms of p an approximate value of 5 when x is equals to 6 plus p, where p is small. When x is equals to 6 plus p, so that means the initial value of x is 6, right? So first I'm going to write down the working formula. We have change in y upon change in x is equals to dy over dx, right? So you need to give it a try first, but let me tell you what you need to be done. First we need to find out, dy by dx at x is equals to 6. After that you need to multiply dy over dx times delta x and that will be your answer. So for this part again you have a time of 2 minutes to give it a try, so start. Alright, so first thing, dy by dx we got in the previous part, it's 5x under root 2x minus 3. The value of x we have at 6, so dy by dx at x equals to 6 equals to 5 6 are 30 times 2 6 are 12, 12 minus 3 it's 9. So 30 and root of 9 is 3, so 30 times 3 it's 90, that is my dy over dx. Change in x is what? It's p. So change in y, it's 90 times p, and that is your answer. Alright, so I hope that you had done it. That part is very simple because we have attempted the same concept previously. So the past paper question is basically the gist of all the topics, subtopics we have learned in chapter number 15 till 19. And you need to recall all the concepts so you won't face a problem while attempting past paper questions. Moving on towards the next question. It's from 2005, June 2005, paper 2. A curve as the equation, this one, find an expression for dy over dx. So first you need to give it a try by yourself. Time for the first part is 2 minutes, so start. Alright, so for the first part you need to apply u upon v here. So u is equals to 8 and derivative of u it will be 0, and v it will be equals to 2x minus 1, and the derivative of v it is equals to 2. Alright, so now we need to apply the working formula here. Since it's u upon v, so in the denominator it's v square, v is 2x minus 1 whole square, v 2x minus 1 derivative of u it's 0 plus minus u that is 8 and derivative of v it will be 2 only. Right, so that is minus 16 divided by 2x minus 1 and its whole square. Now if you observe that this first part dy by dx can be easily solved without applying u upon v, and the fact that I am saying about it is this: in the numerator 8 is a coefficient, not the function, right? So if you have a question that how we are going to apply solve without u upon v, so first it will be y is equals to 8 2x minus 1 with the power minus 1, right? When you shift the denominator in the numerator, the power will be negative 1. And then we need to apply the chain rule, also not the chain rule, the power rule of differentiation. Although you will end up with the same answer, but the correct approach is, if you have a constant in the numerator, then there is no need to apply u upon v. U upon v and u into v only applies when there are two functions, they are multiplying, dividing, etc. Alright, so that is the first part, and this is the answer. For the next part, again it is a chain rule, and it says, given that y is increasing at a rate of 0.2 units per second, that means its dy over dt is 0.2 units per second, right? That is given. When x is minus 0.5, find the corresponding rate of change of x. So what you need to find out? You need to find out dx upon dt. Alright. The chain rule we have, it's dy over dt is equals to dy over dx times dx over dt. For dy over dx, the value of x is given, and that is 0.5 with the negative sign, right? So we need to find out dy over dx at x is minus 0.5, so it's minus 16 divided by 2. X is minus 1 upon 2 minus 1 and its whole square, right? So now it will be 2 and 2 cancels, so minus 16 divided by minus 1 it's minus 2, and minus 2 square is 4, and 16 divided by 4 it's minus 4. So that is the value of dy over dx at x equals to minus 1 upon 2. We are going to use the value here, so dy over dx is minus 4. Dx upon dt is what we are looking for, and dy is 0.2. Alright, So now you need to solve it. 0.2 divided by 4 with the negative sign, it's 0.05. So dx over dt is minus 0.05, and that is your answer. Alright, so after this question, moving on to the next one. It's December 2005, paper 2. Given that y is equals to 1 plus ln of 2x minus 3, obtain an expression for dy by dx. So you need to derivate the function. It is very simple, and for that part you have a time of 90 seconds to give it a try. So start. Alright, so when you are going to derivate the function y dash dy by dx, derivative of 1, it's 0 as it's a constant, plus the derivative of ln is what we had learned, that whatever written inside the bracket you need to write it in 1 upon and this whole bracket, and the function that we have written in the denominator we need to find out the derivative. So it's 2, and the final answer is 2 divided by 2x minus 3. That is your derivative of first part. For the next part, find in terms of p the approximate value of 5 when x is 2 plus p, where p is small. So for change in x, it's p, the x initial value it's 2, right? So the working formula we have, it's delta y over delta x equals to dy over dx. So first we need to find the value of dy by dx at x equals to 2, and then use this working formula, and for that part you have a time of 2 minutes. So start. Alright, so delta y divided by delta x is p is equals to dy by dx, it's 2 divided by 2x minus 3, and we need to find the value when x is 2 here. Alright, so that is very simple. It's 2 divided by 2 2s are 4 minus 3, it's 2 divided by 1, it's 2, and delta y over p. So delta y is equals to 2 times p here. Right, we need to find out the approximate value of y. So value of y is equals to initial value of y plus change in y, right? That will be the final value of y. For initial value of y, we have y is equals to 1 plus ln of 2x minus 3. The value of x is 2 here. So at x equals to 2 equals to 1 plus ln 2 2s are 4 minus 3, it's 1, and then 1 of 0. So y equals to 1. So if you place the value here, so y is 1 plus change in y is 2p. So that is the approximate value of y. Alright, so if you have a question that how we are supposed to know that we need to find out, we need to add the value of y into change in y. So when it says value, it means you need to find y plus change in y. Alright, but if it says approximate change, so you need to just highlight the change in y, not the value of y. That means there is no need to add the value of y. Alright, so I hope that you have a good idea how to solve the past paper questions, and it's better if you try the past paper questions by yourself. Of course you will face a lot of queries, but it will be very good for you if you start past papers for those topics which we have covered so far. Alright, so I think that is quite enough for today's class. Inshallah, in next class we are going to continue with the topic. Till then, take